In this video, we're going to use functions to develop a menu-driven calculator. And here's a description of how this is going to work. I'm going to begin with a user option to see instructions, and then always have a current value that always begins at 0. Then a menu-driven operation, a menu loop, which offers 4 arithmetic operations: addition, subtraction, multiplication, division. Each of these operations will ask for one number to combine with the existing current value to produce a new current value. Floating point values only, and the user will also be able to clear the current value back to 0 and of course exit the program. That'll be one of the menu options. We'll begin by seeing this sample of the desired behavior. So welcome to the Visible Calculator. Do you want instructions? So this is the offer to see instructions. If the user types Y, then we see some brief instructions saying how the program works, and then the primary loop, we see what the current value is and the menu. Enter a choice. So to put in a number, we have to add it in. Add what to 0? Say 17. All right, so now the program shows us what it did. 0 plus 17 is 17. And now we come back to the menu. Current value 17. What do we want to do now? Let's say subtract. Subtract what? Subtract, say, 6. 17 minus 6 is 11. Current value is 11. What next? Okay, so let's say multiply. Multiply by, let's say 19.5. 11 times 19.5 is 214.5. Current value. Divide. Divide. Current value by what? Say, 3. And there it is. All right, so, and then you can clear the result at the current value at any time, and then when you're through, quit. All right, so the idea here is that we have a result variable, the current value, that is maintained throughout the course of the program. Having seen now how this is supposed to work, I'm going to create this. All right, we begin the implementation with a basic program and a couple of messages, a welcome message and a closing message. So we'll see how that compiles and run it just to see the messages. And there we are. Next, we want to ask if the user wants instructions. All right, so we'll do something like this. Print a question and then read the user's response, keeping only the uppercase version of the very first letter of the user's response. If that response is a yes, a Y, then we're just going to call a function to show the instructions rather than embed the print statements right here to illustrate how we can keep main very, very general and high level without getting into a lot of details. This, of course, won't compile. We need to have this function. All right, that'll go down here. All right, that'll look like that, just a print statement with basic instructions. All right, so now we can compile and execute and either see the instructions or not. Once we've offered the user a chance to see the instructions, we want to go into the main loop. We're going to use 0 parameter void function for that as well. We'll call it menu loop. Right? And this will have everything else that the program does. Right? We can put that here. Void functions, right, as soon as you have a header and braces, right, you can compile with the call. And everything's fine. All right, so what's going to happen in this function is we're going to set a variable, which is our for our current value. And this is going to be the current calculator result. Then we have to set up a menu loop. All right, so this will be a loop that executes as long as the user doesn't choose to quit. All right, so I'm going to set up a variable, a char variable, just to some arbitrary letter, and then say while the choice is not Q. All right, well, this will certainly be true the first time we see this condition because choice is a lowercase x here. Lowercase x is not a capital Q. All right, so the loop is going to execute. But now this will compile, but it's an infinite loop because choice is not Q and it never is going to become Q because there's no input statements in here. There's no way for choice to change. All right, so what we're going to do at the beginning of the loop is show the current value and then ask what the user wants to do. That'll look like this. All right, and we'll do the same thing with choice that we did with the instruction prompt. We'll take the next thing the user types, convert it to uppercase, and just look at the first letter. All right, this now will exit. Doing instructions, yes or no, doesn't matter. All right, so the only thing that happens now is we just keep seeing the menu over and over again until we enter a Q for quit, and then it ends. Notice I can put in a lowercase q, and it gets converted to a capital Q here. All right, and there we go. All right, so after this point, we want to put in a switch statement to branch according to whatever the user's choice is. One of the 5 operations. We're going to use a switch statement for that. And that'll look like this. That'll start off like this. Switch choice, because that's the variable that we're branching on. And let's start with an A. So let's have case A, and we'll just say break right now. And then a default. And the default is if the user enters something that's not in the menu, we'll say, put out an error message. Instructions and add. Okay. All right, subtract, though, says an unknown command. Please try again. Multiply says unknown command. Please try again. Only add doesn't give that message because that's the only case we've put in so far. All right, so we can put in the rest of the cases. All right, but first, I'm going to put in actually what we're going to do when we add. All right, and that's going to be a function. All right, look like this. We're going to add to current value, but we're going to get a current value back. All right, so we're going to send the current value to a function, and then this function is going to send an updated value back, which we will assign to the same variable, the current value. So that's how all of these will work. And we'll do add first, and then model the rest of them off that. So we need a function here. This is not a void function. It's being used on the right-hand side of an assignment statement, so the type has to be compatible with the variable we're assigning to. Current val, this left-hand side, this is a double, so the function has to be a double. Add to, and we have that. And we'll just, for right now, we'll just return the value. Let's quit that. All right, add. All right, so it doesn't change anything, all right, but it works. All right, so we quit. there. All right, so what is the add function going to do? Well, it has to ask for the value that we're going to add them together, and then return the updated value. So that's going to look something like this. So in the print statement, I'm going to repeat the value, just as a reminder to the user what we're adding to, and then ask, okay, add what to the value, and then read in the operation. Now I need an updated value, and that's what we're going to return. And maybe we show a print statement as to what took place in the function. Right, something like this. We just show the equation and what the result was before we send it back. Updated value. All right, so let's see if we can add instructions. Yes. Okay, so we see the instructions, and now if current value is 0, I want to add what to 0? Let's say 3. Okay, 0 plus 3 is 3. Current value is 3. Add again. 6. 3 plus 6 is 9. Current value is 9. Add 8. 9 plus 8 is 17. Maybe that's all we have. Quit. Unknown command. That shouldn't be an unknown command. We want to handle quit. So we need a case for that. I'm not going to call anything, but we do want to show the value one last time before we stop the program. Okay. Something like that. Let's try that again. No, add 3, add 7, add 5, 10 plus 5, 15. And when we quit, there we go. Ending with a current value of 15. Thanks for using the calculator. And then we're finished with the add method. All right, so we can model the other operations off this and get something like the following. Case S for subtract. So the other three operations are very similar, different function, because we're going to do a different operation. And then the last thing we have is clear. We don't need a function for that. So all we're going to do is reset current value to 0, and we can just do that directly in the menu loop. And we're ready to give that a try. So add 4, subtract 8. We can handle negative numbers. Divide by 3. And we get fractional portions. Multiply by 3. Try out the clear. Clear resets to 0. Quit. Quit shows your last value. And there's your calculator. So we added functions here, and modeled those functions off add, just with a different prompt, subtract, multiply, or divide. So we changed the prompt because we're asking for something different. And clearly we changed the operation that we're doing. And then changed what we were saying, okay, either minus, times, or divided by, so that we can be accurate in what was taking place. And there's our calculator.